Hello there and welcome to A-Level Maths. Here we're looking at the expansion of a plus bx to the power of n, so we can answer questions from exercise 4b. So what we're going to be looking at here is an extension from exercise 4a where we looked at 1 plus x to the power of n. This time we've got a different coefficient at the front that's being added on, and we're going to look at how we can just simply adjust this expansion to the previous expansion in exercise 4a and then apply the formula from exercise 4a. So let me show you two examples and then we'll go through one together. So the question here is, find the first four terms in the binomial expansion of the square root of 4 plus x. So the way we're going to treat this as a binomial expansion question is to treat the square root as a power of a half. So you can see up here the famous binomial expansion that we saw in the last video, 1 plus x to the power of n. So n here is representing a half, but the 1 here that we know and love in our formula because it simplifies a lot is now a 4. So we're going to look at how to deal with that. So what we're going to do is we're going to effectively factorize 4 out of this bracket. But remember, all of this bracket is being to the power of a half. So when I factorize it out, the 4 is going to come out with a power of a half on it. Let me show you that in 2 steps, but you can do it in one later on. If we factorize a 4 out of this little bracket here, it's going to be 4 brackets 1 plus, and then there isn't a 4 in this x, so you just have to write it as x over 4. You can see if you were to expand it back in, you would get x again. So let's treat this as now x over 4. And now if we're going to split up the 4 and this bracket here, the 4 also needs to be powered as well as the bracket. So you're going to expand these square brackets here by doing 4 to the power of a half and the bracket to the power of a half. And we all know that 4 to the power of a half, that's 4 square rooted, that will simplify to 2. So what we've now got is a coefficient at the front of the bracket, outside of the expansion, where we now do the expansion using the formula up above, and then we'll just multiply all our answers by 2 at the end. So let's now write out the general form for 1 plus x to the power of n. You can just grab this from your formula booklet. And this time n is going to be a half and x is going to be replaced with x over 4. So let's write out the formula. Let's always start with a 1 and then plus a half times x over 4. That's the n value and the equivalent x value. Let's move on to the next bit. It's going to be n minus 1. And then x squared, you're going to square all of the x over 4, so x over 4 squared, and then all of that over 2. And we'll do one last term, a half minus 3 over 2, x over 4 cubed, all over 3 factorial, which is 3 times 2 times 1, that's 6. We can simplify all of our coefficients there, just grab your calculator and simplify them all in turn, like that. Our final answer here is going to be the binomial expansion for 4 plus x square rooted, so we're going to need to multiply by 2 here. So multiply each term by 2 to get the full binomial expansion answer for this question, and it's this expression down the bottom there. Okay, so we now need to move on to consider when we can use our binomial expansion. Generally, in the formula booklet, at the end of the formula, it will say when mod x is less than 1. But in this case, for this question, x was x over 4. So in the modulus symbols they go, modulus of x over 4 is less than 1, and we can multiply out that 4 because it is a positive value. We can always multiply or divide out positive values from moduluses. And the mod of x is less than 4. That means that x is in between minus 4 to 4. So there we are. This is the answer down below here. This is the answer to the binomial expansion of the square root of 4 plus x that is valid for these values of x down here. So there we are. It's factorize out the a term at the front, but also don't forget to attach the power to it as well. Let's have a go at another question then. This one here is 1 over 2 plus 3x all squared. So again, we'll rewrite that as a bracket to the power of n. So that's 2 plus 3x to the power of minus 2. So we're now going to factorize out this power of this number of 2 at the front of the bracket here. So we're going to factorize it out of that bracket. So it's now going to become 1 plus 3x over 2, all to the minus 2, and then we can expand those square brackets by doing 2 to the minus 2 and the bracket to the minus 2 as well. So 2 to the minus 2 and then the bracket to the minus 2. And 2 to the minus 2, we all know the rules of indices there, that would be 1/4. So the next thing we now need to do is do the binomial expansion on the bracket at the back there. So 1 plus x to the n, we know that from the formula booklet, and 1 is still in there. X is now going to be replaced with 3x over 2, and n is going to be replaced with minus 2. So substitute all of them into the formula. 1 plus n is minus 2, x is 3x over 2, then it would be minus 2 times minus 3, 3x over 2 all squared, divided by 2, and one more, minus 2, minus 3, minus 4, 3x over 2 all cubed over 6. Work out each term, grab your calculator, simplify each term, and we get these 4 simplifications here. But for our final answer for what the binomial expansion of the question was, we now need to multiply all of these by 1/4. So it's going to be 1/4 minus 3/4 x plus 27 over 16x squared and minus 27 over 8x cubed. So there we are. This is the answer to this question. Now we just need to work out what values of x this is valid for. So remember, it is at the end of this mod x is less than 1. And in this binomial expansion here, we used x as 3x over 2. So it's when the mod of 3x over 2 is less than 1, and we multiply out the 2, divide out by the 3. You can always do that with positive values. And there we are, mod of x is less than 2 over 3. So those are the values of x you're allowed to put into this function, and this is the binomial expansion. So there we are, a couple of different examples there. We'll now have a go at one together then. Pause the video and give this question here a little go. Okay, let's get started on this question. And so the first thing I would do to answer part A is to write m of x as a power around a bracket. So it'd be 4 minus x to the power of 1/2. Okay, so the next thing I need to do is factorise out the 4 to the front of the bracket, and its 4 is going to be factorised out with the 1/2 on it. So 4 to the power of 1/2. And then it's going to be 1 minus x over 4. Don't forget to factorise out the 4 from the x as well. Classic student mistake is just to factorise the 4 out of the 4 at the front to make it 1 without doing it to the back term. Make sure you definitely do it to the back term. That's something you can check when you go through your binomial expansion answer. Okay, so we'll simplify that to 2 bracket 1 minus x over 4 to the power of 1/2. Now we'll write out the binomial expansion for this term here. Remember, it's 1 plus nx plus n minus 1 x squared over 2. And that will be up to the x squared term. So it'll be 1. In this binomial expansion from here to here, n is 1/2, but x is going to be minus x. So minus x over 4. So remember that the minus also goes on the x, and that's how the minus is taken into account. So it's then going to be plus 1/2 times minus x over 4, and then it's going to be plus 1/2 times minus 1/2 times minus x over 4 squared all over 2, and that's where we'll close the brackets. So let's simplify before we multiply out the 2, so it'd be 1 minus x over 8, and then it's going to be negative, negative, negative. That's a triple negative, so that'll make it a negative. 1/2 times 1/2 times a quarter times a quarter times another 1/2. That'll be 8 times 16. Let's just grab my calculator so I don't make any mistakes. X squared over 128. And then when you multiply out the 2, it's going to be 2 minus x over 4 minus x squared over 64. And there we are, that's the answer to part A then. What values of x are allowed? Well, the values of x that are allowed are going to be minus x over 4 inside the modulus is less than 1. We can kind of just ignore the minus there because it's going to be made positive by the modulus function, and then times the other side by 4, so it's going to be mod x is less than 4. So we are allowed to put x equals 1/9 into the binomial expansion. So let's go ahead and do that then. On the left hand side, it's going to be 4 minus 1/9 to the power of a half. And this is going to then equal 2 minus 1/9 over 4 minus 1/9 squared over 64. Okay, what do we get on the left hand side? Because these two expressions are equivalent up to the x squared term, so it's going to be 36 over 9, so this is going to be 35 over 9, and that will all be to the power of a half. And this is going to be equal, I'm going to do this all on the calculator now, so I'm going to type in 1/9. And then I'm going to use 1/9 as the answer value and calculate this expression here. So it's going to be 2 minus answer value over 4. And then it'll be minus answer value squared over 64. And that'll be 1.9. We'll write this out to 4 decimal places. 9720. And then it'll be 29320099. Just in case the examiner wants any more decimal places. Now what's happening on the left hand side here? Well, we are going to get the square root of 35 as the numerator, but we're also going to have this divided by 3, because 9 over, so when you've got 9 to the power of a half, that's 3, and that's how you do indices. So this is going to be equal to the 1.9720 ... So we now need to multiply this answer by 3, so answer value times 3 on the calculator, square root of 35 is approximately 5.9161 to 4 decimal places. Why have I done to 4 decimal places? Good question. Well, we're looking for an approximation of root 35. It's not just a standard answer here. We'd like something to be approximate here. Maybe I might do my final answer to 3 significant figures, and the examiner can kind of choose which answer they prefer to take. So there we are. And does this make sense? What is the square root of 35? Let's just type that out on the calculator just to see if we're in the right ballpark. It's 5.9161. Yes, we've got that exactly right to 4 decimal places anyway. Not exactly right, but to 4 decimal places. So there we are. Make sure when you're doing these kind of questions here, you're finding an approximation for root 35. You try it in your calculator to see even if you're in the right ballpark, and then you know if you've kind of done the question roughly correct or not. So there we are, that's exercise 4B on page 100. Make sure you now go ahead and do lots of practice questions. There's some good exam questions, problem solving questions in that exercise. Feel free to ask your teacher if you need any help on these. And yeah, I'll see you in the next video.